Dr. Tanjima Hashem is a professor at the Department of Computer Science and Engineering, CSE, in Bangladesh University of Engineering and Technology, BUET. She received her PhD degree in Computer Science and Software Engineering from University of Melbourne, from Australia. Her research interest falls into the intersection of spatial data management and ubiquitous computing. She has published her works on premium venues like Ubicom, ICDE, SICKIM, EDBT, Pervasive and Mobile Computing and Information System. In 2017, she received the prestigious Elsevier Foundation Award for Early Career Women Scientists in the Developing World in Engineering Sciences. So welcome everyone to this very useful session. So I will be requesting Dr. Tanjima Hashem to make a presentation and a session. Basically, she has been asked to give a talk on the topic titled Efficient Algorithms for Planning and Scheduling Trips in Spatial Databases. Please start.
Thanks a lot for introducing me. Okay, I'm sharing my presentation. Welcome everybody. The widespread uses of location-aware mobile devices has expedited the proliferation of variant location-based services that assist users in planning and scheduling trips in an optimized manner. In today's talk, I will discuss about some of my work on planning and scheduling trips in spatial databases. So this is the outline of my talk. First, I will discuss my approach on group trip planning queries, and then I will give a brief overview on my work about group trip scheduling queries and privacy preserving trip planning queries. So my work on group trip planning queries is a joint work between BUET and University of Melbourne. The advent of location-based social network has enabled now a group of users to become involved in a single location-based query. So users are typically distributed at different places. For example, on a late afternoon, a group of friends might be still at their office or workplaces, but before going to home, they may want to organize a group dinner at a restaurant followed by a joint visit to a movie theater. And all of the members of this group may want to visit their nearby restaurant and movie theater. So to assist the group to plan a trip with the minimum total travel distance, we introduce a new query type, which we call group trip planning query or a GTP query in spatial databases. For example, here in this figure, so there are three users, U1, U2, and U3. We can see the source locations of the users are at S1, S2, and S3, and destinations are at D1, D2, D3. So they would like to visit a restaurant and a movie theater. So there are lots of options for a restaurant and also for the movie theater. So they request a GTP query to know the locations of the restaurant and movie theater that together minimize their total travel distance. So here the total travel distance is computed as the summation of the travel distance of each user's trip. So here in this figure, we can see the circled restaurant, which is P2 prime and the movie theater, which is P1 double prime, together minimize their total travel distance. So trip distance of a user, for example, for E1, is computed as the distance between S1 and D1 via P2 prime and P1 double prime. So formally, for a given for a given n source estimation pairs of n group members and a set of required point of interest types or POI types, for example, restaurant, movie theater, shopping center, and an aggregate function f, a DTP query returns a POI for each required type that together minimize the aggregate travel distance for the group. So for aggregate function sum, GTP query minimizes